All right, so hello everyone. Welcome to the lab for the assignment for lighting. So we are going to discuss how to add lighting effect to your scene, and that's the main objective for this next lab assignment 4. So as usual, first I'm going to discuss a little bit about the requirement of the assignment, and then I'm going to show you some examples. We're going to write some code based on our previous works and show you how to add lighting effects on a specific scenario. So here, as usual, you can see we have lab videos. Today's video is going to be added here, and we have the tutorials here. There is one example. As you can see, we have this previous scenario where we have this wall and the field. The added thing is the sphere. So sphere is the best example simple object that can be used for telling if the lighting is working properly or not. If you use a cube is too simple because it has only 6 faces, right? So the effect of the lighting is not going to be very obvious unless we have a lot of faces, and for each of the faces you need to calculate the lighting separately, right? So that's why the following features are required. You need a cube, at least one sphere in your world. I think you need more than one cube or something like that. Let me go to the rubric. Yeah, you should have at least one cube. You can have more than one cube. You need a sphere. Then you can go back here. You should have a single point light that changes location, probably spinning around your world or just move back and forth. And then a way to tell where the light is. Easiest is just to render a cube at light location, or you can also render a sphere. I go with the cube since this is explicitly mentioned here. You need some method of moving the camera around the object, either rotation slider or keyboard. I think this part is pretty much similar to what you did in the last assignment for your texture. So probably you can use the camera rotation or camera control from this previous one. Each object of the world is illuminated using a Phong shader. So Phong is a lighting technique. We're going to see some more detail about that. This is mostly a shading model. And that model has 3 main components of light that we need to calculate. So the components are the ambient lighting, the diffuse lighting, and the specular lighting. So each 3 components, we're going to calculate that inside the shader, inside our fragment shader, to be more specific, that is needed for the Phong shader. Or another way is to calculate that inside the vertex shader or glow shader. That both of them gives you some sort of lighting, but the requirement here is the Phong shader. Then the specular and the diffuse lighting calculations require the normal of the vertices. For each of the vertices, you need to calculate the normal. So I hope you know the definition of the normal. So you have to calculate the normal of each vertex and pass this as input to the shader. So normal calculation is taking cross product of 2 vectors. That can be done from a triangle, right? If you use the 3 points of the triangle. And then there should be a button to turn the lighting on or off, and a button to turn normal visualization on or off. Then as usual, we have some extras for an A that is defined in the rubric, right? Some additional things you can do here. So instructions are given here. As usual, you can follow the instructions and watch the video from the professor. That should get you started. What we are going to do, we are going to do some more hands-on coding in the lab that would help you to understand how to implement the lighting, right? Okay, so We have some resources like how to calculate the normal here readings. The normal this is more about the normal metrics, I think. That is eventually we are going to calculate. How to use that for each of the normal, that is just the direction of the light reflection on the face, right? So this is the perpendicular line or vector on the face we want to calculate the light, right? So here, as you can see in this triangle, if this is the reflective space, then t is a vector that is tangent, or n is and n is a vector that is a normal. So depending on your object shape, normals are going to be changed. We'll talk about that a little bit more. We have one resource about how to generate a sphere mesh. You can go here and see the basic idea behind creating spheres. But I'm going to show you something else, which is we're going to borrow a lot of today's work from the book. Okay, then we have this example. This is a more visual example, as you can see. There is a knot, and the lighting model is implemented here. There is a vertex shader here, and the fragment shader here. So this is an example of form, how it should look like. So you have other objects like how a cube would look like, very plain, right? Not a lot of stuff to see. But the sphere, on the other hand, would be more. As you can see, this is a rotating sphere. You can see the reflective light here. So we need at least a sphere. A knot would be nicer, or even like a hose or a teapot, but those are more complex objects to create. Either you have to import the object from an OBJ file, or you need to somehow calculate the vertices, which is, I would say, not very realistic task for this assignment. So we'll stick with the sphere, which gives us pretty good sense of lighting. And there is different versions. Like, for example, if it is for vertex form, you can see some sort of artifact. The reflection is not as natural as it should be. So that's what everything is done in the vertex shader. That is what we're going to do. And same thing you pass to the fragment shader. That is what is done here. This is more natural, right? So here only the vertex related calculations are done in the vertex shader. Lighting is calculated in the fragment shader. So this is one example. I added a new example here, which is I like more because you have control over more stuff, like the amount of light for each of the reflection. So again, this is not form, this is Gauss shader. So difference is the same calculation is done in the vertex shader, but for form, it is done in the fragment shader. So we'll see more of that. Here you can see you can change the color, right? Which is also another requirement you need to do. So if you check number 6, you need to add a slider to change the color of your light. So what is the effect of changing the color of your light is here, right? So the specular light, if you sorry, it is not now white. The diffuse reflection, this is the color of the object, but what if I change the specular light to red? This, okay, like this, right? And what is the effect? You can see this reddish reflection here, right? But if it is white, then the reflection is not white. So these are the small details you need to know. And I guess the resources given here in addition to the videos, and also the new video I'm going to add for today's lab is going to be a very good example for working on this stuff. Okay, so this is the overview of the assignment 4.